Hello, this is our second video of examples of topics from section 10.4 in our calculus text. This video is going to focus on the difference between absolute convergence and conditional convergence. We'll look at some examples of what we can do with this. So first of all, let's remind ourselves of what absolute and conditional convergence are. So we're going to assume up front that we have a convergence series. So we've done some tests, some appropriate tests, and we've decided that the series that we've got in front of us is convergent. So there are two statements to make. So what we're going to do is we're going to look at the sum of the absolute values of the terms. So remember, we're taking absolute value first and then adding together. So this is shorthand for absolute value of A1 plus the absolute value of A2 plus the absolute value of A3, etc. If this is also convergent, we say that summation A sub n is absolutely convergent. But if we take the absolute value of all the terms, add them up, and that turns out to be divergent, then we say that summation n equals 1 to infinity a sub n is conditionally convergent. Okay, so we already have a convergent series, and what we're doing now is we're taking the absolute values of all the terms and asking, does that series converge? If the answer is yes, then the series that we start off with is absolutely convergent. If the answer is no, then the series we start off with is conditionally convergent. So our first two examples here are series that we looked at in the previous video when we were just determining whether or not they were convergent or not. And these were both convergent by the alternating series test. So we already know that this series is convergent. And so the question we want to ask is it absolutely convergent? Well, to answer that question, we look at summation n equals 1 to infinity, the absolute value of negative 1 to the n plus 1 times 1 over n cubed. And what we want to remember is that, well, I'll do it in a couple of steps. The first thing we can do is we can remember that the absolute value of a product is the absolute value, is the product of the absolute values. And we want to recognize that this right here is just 1. If I take negative 1 and take the absolute value of it, I get 1. If I take the absolute value of 1, I get 1. So no matter whether this is negative 1 or positive 1, that's 1. And this is just 1 over n cubed because n is a positive number. So the absolute value of a positive expression is just that expression. And so what I wind up getting is I get summation n equals 1 to infinity 1 over n cubed. Well, we know a little bit about that. This is a p-series. With p equal to 3, which is definitely bigger than 1. So this converges. So if this series converges and this converges, then we say that the original given series converges absolutely. And so the absolute here is referring to adding up absolute values of all the terms. Our next example was another alternating series. We've already showed this converges. And so, is it absolutely convergent? Well, again, we'll look at the absolute value of all these terms. And by our work earlier, we want to recognize that this is going to be summation n equals 1 to infinity of 1 over the square root of n. This is also a p-series with p equal to 1/2, which is less than or equal to 1. So this is divergent. So when this is convergent, this is divergent. That tells me that the series I was given originally converges conditionally. So again, some steps we can take. We can look at the series as given, decide whether it converges or not, and then look at the series formed by adding up the absolute values of all our terms. And if that series converges, the original series was absolutely convergent. If that series is divergent, then the original series is conditionally convergent. So let's take a look at this third example, summation n equals 1 to infinity sine n over n to the 3/2. This is not alternating, because sine n does oscillate between positive and negative values, but it doesn't oscillate every other one. And so this is not alternating, so I can't apply the alternating series test. And in fact, what I'm going to do is I'm going to let you in on sort of a shortcut to determine about absolute convergence or convergence of the series. So here's a note. If a series converges absolutely, then it converges. So what I'm going to do is I'm going to tackle, in this particular example, I'm going to tackle the absolute convergence piece first, and then we'll be able to draw the conclusion that it converges from that. So, if it's absolutely convergent, that automatically means that the series is going to be convergent. So let's see if we can show that this series converges absolutely. Well, so I'm going to examine this. Well, let's take a look at the absolute value of sine n over n to the 3/2. Now I know the denominator is already positive, and so taking the absolute value of that is redundant. And so what this really is the absolute value of sine n over n to the 3/2. And one thing that I remember about the sine function is that it always takes on values, no matter what I put into it, it always takes on values between -1 and 1, which means that its absolute value is always less than or equal to 1. So let's make a note of that. So let's recall that the absolute value of sine n is less than or equal to 1. Well, let me apply that idea here. So that would mean that absolute value of sine n over n to the 3/2 is less than or equal to 1 over n to the 3/2. And, well, what about this thing again? That's a p-series, right? And so, or it's the terms of a p-series. So summation n equals 1 to infinity 1 over n to the 3/2 is a convergent p-series. p is 3/2, which is bigger than 1. So let's think about this. I've got a sub n here, which I'll call absolute value of sine n over n to the 3/2, less than or equal to b sub n, and summation b sub n converges. That actually sounds like the direct comparison test. And so what we get to conclude then is, by the direct comparison test, summation n equals 1 to infinity absolute value of sine n over n to the 3/2 converges. So what that tells me is that summation n equals 1 to infinity sine n without the absolute value symbols over n to the 3/2 converges absolutely. And so it also just simply converges. Our next video will talk about estimating sums of convergent alternating series.